Now I want to work two more problems of simplifying exponents. And these two problems might look a little ugly, but when you see a problem like this, don't panic, just follow the rules and eventually they end up not being too difficult. So the first one, 3x to the minus 2 y z cubed, and all of that raised to the negative 2 power times, in parentheses, xy squared z to the minus 1, and that parenthesis raised to the third power, and all that is going to be over, in parentheses, 2 x squared y squared z to the minus 2. All right, so it looks a little ugly, but let's just follow the exponent rules and we can begin to simplify this. And let me just make a note that with problems like this, there are at least 2 or 3 or probably 4 different ways to go about simplifying this. And I'm going to simply do here what I think to me seems like the easiest way to do it, but you may choose to apply the rules differently, but you should end up with the same answer. What I'm going to do is I notice I have 3 parentheses here. I'm going to go ahead and get rid of those parentheses by using the power rule and applying the exponent to all the factors inside. So for this first one, there are 4 factors inside. When I get to this parenthesis, 3 factors and 4 factors again. I'm going to try and do some of these in my head just to save time. Although this first one, I'm just going to write out 3 to the minus 2, because we'll have to think about that in a few minutes. X to the minus 2 raised to the minus 2 power. That's how we multiply the exponents, right? So it's going to be x to the 4th, since minus 2 times minus 2 is 4. Y to the minus 2 power. Z cubed raised to the minus 2 power. It's going to be z to the minus 6. We multiply 3 times negative 2. For the second set of parentheses, we'll have x cubed. Y squared raised to the third power is y to the 6th. Z to the negative 1 raised to the third power. We multiply 1 times 3. And that's z to the minus 3. And now let's get rid of the parenthesis in the denominator. Once again, 2 raised to the minus 2 power. We'll take care of that in a few minutes. X squared raised to the minus 2 power. X to the minus 4. Y squared raised to the minus 2 power. Y to the minus 4. And then z raised to the minus 2 power. Now what I'm going to do, and you don't have to do this, but I'm going to go ahead and get rid of all the negative exponents. Although an option is, especially in the numerator and denominator, I could go ahead and use the product rule to go ahead and multiply out, especially in the numerator, some of those variables. And actually, the more I look at it, I think I might want to do that. So let's go ahead and do that. Let me just leave the negative exponents for now. In the numerator, I have x to the 4th times x to the 3rd. That's x to the 7th. I have y to the minus 2 times y to the 6th. Product rule says multiply 2 exponents, same base, you add the exponents. That's going to be y to the 4th. And for my z's, z to the minus 6 times z to the minus 3. Add those exponents, z to the minus 9. And for now, I'm going to just leave this denominator. And now, I think I'll go and get rid of all the negative exponents. So once again, to make a negative exponent positive, you simply flip the exponent. If it's in the top, it goes to the bottom. If it's in the bottom, it goes to the top. 3 to the minus 2 is now going to go to the denominator. X to the 7th is okay, it's a positive exponent. Y to the 4th just stays. But z to the minus 9 goes to the denominator as z to the 9th. Now if I go to the denominator, 2 to the minus 2 goes to the numerator as 2 squared. X to the minus 4 goes to the numerator as x to the 4th. Y to the minus 4, y to the 4th. And then z to the minus 2, z squared. So now I don't have any more negative exponents. So now, let me look at using the product rule, especially in the numerator. First of all, let's take care of the 2 squared. That's 4. And on the bottom, the 3 squared is 9. Now in the numerator, I have an x to the 7th times x to the 4th. Product rule says you add the exponents, x to the 11th. Y to the 4th times y to the 4th is y to the 8th. And I simply have a z squared here, nothing to multiply it by, and a z to the 9th in the bottom. Now the last step is, since I have z squared at the top and z to the 9th in the bottom, you could use the quotient rule, but I prefer just to cancel. Anytime you have positive exponents, you can always just cancel. So really what I have here, let me first write 4x to the 11th, y to the 8th, and now z squared over z to the 9th, I can think of that as I have 2 z's in the numerator and 9 z's multiplied together in the denominator. If you cancel out 2 z's in the top and the bottom, of course you're left with z to the 7th. And now we have simplified that exponent. Let me do a second problem. Actually doesn't look quite as messy as that one, but I want to highlight one tricky thought in this one. So we have 4a squared b, all that raised to the minus 3 power, and then minus a cubed over 2b, and this whole thing squared. All right, maybe it doesn't look that bad to you. So let's go ahead and start it. I'm going to go ahead and apply the power rule to get rid of these parentheses. So once again, the minus 3 gets applied to all the factors inside. So 4 to the minus 3. A squared raised to the minus 3 power becomes a to the minus 6. And then b to the minus 3. Now if I look at this second parenthesis, here's where it's a little tricky. And I'm looking at this minus sign, because really, in a sense, that 2 really gets applied to the minus sign, to the a to the 3rd, to the 2, and to the b. As a matter of fact, sometimes the safest thing to do when you have a minus like this, I'm going to sneak in here and actually write that as a minus 1. Minus a cubed is the same thing as minus 1 times a cubed. Now it makes it easier when I'm applying this power rule. I now have minus 1 squared, then a cubed squared is a to the 6th over 2 squared, and then b squared. Now, let's go ahead and let's combine with the product or anything we can. I notice a to the minus 6 times a to the 6th, same base. You add the exponents. What's minus 6 times 6? That's 0. You end up with a to the 0. A to the 0 is just 1. So actually, if I want to, I can almost just sort of cross these out, because in a sense they cancel out. And now let's get rid of this negative exponent here. So 4 to the minus 3 is going to go to the bottom as 4 to the 3rd. B to the minus 3 goes to the bottom as b cubed. What is minus 1 squared? Minus 1 times minus 1 is just 1. I'll just write that at the top. Now I go to the denominator. 2 squared is 4. And then b squared. So it looks like I don't have anything in the numerator. It's all in the denominator. And now 4 cubed times 4 is like 4 to the 4th. And I think if I want to write that out, 4 times 4 is 16, times 4 is 64, times 4, I think it's 256. Now b squared b cubed times b squared, product rule says you multiply two exponents, same base, you add the exponents. That becomes b to the 5th. So when you're all done, you have 1 over 256 times b to the 5th.